Hopefully you can hear me, hopefully you can see me, and hopefully you can see my slides. It's 8:01 p.m. on my clock, so 2:01. Hopefully you've joined the English speaking channel because that's the language I'll be speaking in. My name's Conor McDonald. Welcome to this webinar. Normally I would be at Apex Connect, but yes, obviously we're doing it virtually, which I have to admit makes the travel a little bit easier for me. I live in Australia, and it's amazing how much the world has changed, where literally only 2 months ago, the slide I would put on was talking about how the bushfires in Australia had affected so many people, and yet this is now the picture we show. It's a very different landscape. I won't dwell on the negatives, obviously, but all I will say is, if we're doing things with user group events, things that involve the user community, then obviously we need users. So I will just reach out to say, wherever you are in the world, just make sure you're staying safe and that the people who are around you are staying safe as well. I love talking tech, so this is how you get in touch with me. I have a blog, I have a Twitter handle, I have a YouTube channel, depending on what your flavor is, whether you like the written word or video, etc. Please, I love talking technology, so please get in touch whenever you like. We're talking about Flashback today, and when we talk about Flashback, people often think of it's the emergency option. It's something I would never use, regularly. It's just something I would use in case something is wrong. As Apex developers, the most common example we think of in Flashback is this: oh my goodness, I've screwed up my app. Let's go export it as it was 10 minutes ago when it was still working, and I'll re-import that and see how we go. A word of warning, we had massive storms here in Western Australia last night. I lost a few trees, and we've had power outages all day long. If in the next 45 minutes things go blank, I have a laptop on backup with a battery. I have hopefully my mobile on 4G, and I have some lighting, just a little battery powered torch. So if it all goes blank, give me 3 minutes and I'll be back online with a somewhat more subdued experience, but hopefully we won't have it in the next 45 minutes. Flashback, I've titled this so much more because it's so much more than just the emergency option. And the key thing is, there was a time when Flashback probably was just an emergency option for you, but the way that the IT landscape has changed actually lends itself to Flashback being a much more rigorous part of your day-to-day development lifecycle. And hopefully I can justify that to you. Now, Flashback is actually several different technologies under the same banner of Flashback. There's actually 6 of them. There's Flashback Query, Table, Drop, Database, Transaction, and Data Archive. 6 technologies, 41 minutes. We'll do our best to get through them all. So we're just going to get straight into it now. Let's go into Flashback Query. A bit of controversy, always to get you energized for the session. Everyone on this call, even if you've never used Apex, has been using Flashback Query. Now, to talk about why that's the case, let's do a bit of revision, a little bit of internals revision to set the scene for how Flashback Query works. One of the cool things about an Oracle database is you can change data and then change your mind and hit the rollback command. It's one of the great things about the Oracle database. If you make a mess, you can dig yourself out of it as long as you haven't committed. The question is, how does rollback work? It's pretty simple. We remember stuff. And to dive into a little bit of internals, let's see what happens when you try to do an update or a change to some data in the Oracle database. Before you're allowed to even commence, the database gives you a spot, effectively an entry point into what we call the undo segment, the undo segment header. We've been given slot number 5, and then we're allowed to proceed. If I'm going to add 10% to the employee called Smith, the first thing I do before I even touch that data is I mark that block with where to find the undo information, and then I store how to undo that transaction. People often think we take an entire copy of the entire block, stuff like that. We don't. We just store effectively a list of instructions. If I'm going to change the salary back from where it was after the update, I would go to block, in this case 2754, row number 1 just happens to be Smith, and change the salary back to 1,000. Once that's done, then I can see that change to Smith go up to 1,100, the 10% increase. And that way, we've stored how to get out of this mess before we go ahead and do the update. When you type in rollback, we go to the block, we see that it's undo slot 5.1, That lets us navigate to the undo information, find that instruction, go to block 2754, row number 1, and change the salary back to 1,000. That's a vast simplification, but that's in a nutshell how rollback works. Now, how does this relate to Flashback? Way back in Oracle 4, someone said, you know, we could use this stuff for queries. And that introduced probably the #1 feature that appeals to everyone who uses Oracle, the concept of read consistency, or the readers don't block writers, writers don't block readers. Let's look at how that would work in a real life situation where we are allowed to do read consistent objects or read consistent queries by using the undo information that we just saw that underpins transactions. Session 1 comes along at 9 a.m. and starts querying the employee table. Let's assume our employee table is huge, so it's going to take a long time. The cool thing about Oracle is that doesn't stop anyone else touching your session or touching your data. Session 2 comes along at 9:03. You can see the time going down the side there, and doesn't update. And it changes the employee name from John to Sue for that particular employee. Let's assume that particular row of data sits on block 3217. That's one of the blocks of the employee table. At 9:05, long after session 2 has updated and committed, session 1, which is running this query from 9 a.m., stumbles across block 3217 and says, I need that data, but to give a consistent view of the data, I need it as it was at 9 o'clock. Now that data got changed at 9:03 a couple of minutes ago. So what do? Other databases would block you such that you could never get into this situation, but Oracle lets us do this. To get information as it pertains to time in Oracle, we need to understand a thing called the SCN. The SCN stands for System Change Number. You could think of it like an internal timestamp in the database. So block 3217, before any of those 2 sessions started, had the employee name of John and a timestamp or SCN number of, say, 003. Session 2, the one that made the change, came along at 9:03 and said, yep, change the employee name from John to Sue. Because I've changed that block, we log with that block a new SCN, a new timestamp, 9:03 being SCN 234, for example. Because that's a normal transaction, as we saw in the little demo before, that must record some undo. We have to record the information on how to undo that transaction should they do a rollback. So how do I undo it? I would go to block 3217, change the SCN back to 003 and change Sue back to John. That goes in the undo for session number 2. Session 1 comes along at 9:05 and says, I need block 3217. And because the query started at 9 o'clock, I need it as of SCN, and I'm inventing this, at 192. That's representative of 9 a.m. It will see block 3217 as it is now. It says, oh, it's SCN 234. That's no good for me. I need it at 192 or earlier. So it says, that's no good. I'll take a copy of that block in the buffer cache, and then I'll go get the undo from, not from my session, but from someone else's. I'll go get session 2's undo and roll back that transaction. Go get the undo and change the block from SCN 234 back to SCN 003, and the employee name goes back to John. 003 is less than 192, which is the SCN I needed. I'm good to go. That is how read consistent query works. We are actually undoing other people's transactions on the fly. So every query you ever run in the Oracle database is actually locked at a SCN number or a timestamp. At when the point query started, all the data you get is locked at that point in time. All Flashback Query is just an extension to that exact same functionality, except you get to nominate the SCN. It's not the particular time the query started, you get to choose. It's actually been around since version 9. This is pretty robust technology because Flashback technologies came in way back in 2001. They're almost 20 years old. They're pretty rock solid. So if I do select from department table, it says, oh, the department name is unknown. Someone's gonna mess with my data. That's a normal query. Even that query we know is locked at an SCN at the time the query started. This is what a Flashback query looks like. We simply say, I want the data as of a particular system change number. Now, I don't know about you. I don't have system change numbers just rolling off my tongue. So obviously I would normally want to use a timestamp. So if you want to do something a little less geeky, I can actually do a timestamp. Now, as you know, timestamps are related to intervals if you want to do timestamp arithmetic. So in this example, I've said, go and get the department table as of sys timestamp minus a 20-minute interval. So go see the department table as it was 20 minutes ago. As we can see on screen, effectively, we've only got the department names have come back from unknown to their normal accounting, research, etc. So somewhere in the last 20 minutes, someone changed that data. But that's a flashback query. I'm looking backwards in time to a nominated point in time. If you need to toggle between SCN and timestamp, we have some delivered functions that let you do that. We have timestamp to SCN and SCN to timestamp. The reason we do that is sometimes if you want to get really, really granular, you want to get a change on a particular SCN number, you can actually use a timestamp to find a range of SCNs and then pick the particular transaction you were interested in if you want to get that granular. Typically, you're looking for a much broader time frame. The cool thing is you can use it in just normal queries as well. It's not like some specially compartmentalized functionality. Here I've got a query against the employee table joined to the department table as it was a little while ago. So the employee table as it is now joined the department table as it was sometime in the past. I can mix and match. At which point you're going, what's in it for me? Why would I want to see a table as it was in the past? Obviously there's this one. We're familiar with this, the get out of jail card in Apex. Funnily enough, as we saw in Carsten's keynote, this will probably become less and less popular over time because we have now the automated backup regime coming in Apex 20. But there are other things. Unit testing. One of the key things we do with unit testing is we look at a picture of the data before we run our unit test. We then do our unit test. We look at the picture after the unit test, and we often compare and contrast. That's how we can make a decision as to whether the unit test failed or not. Now, before Flashback, or if you're not using Flashback, that can be a real pain. We have to capture that original image. Often we take a backup into a table. Or in applications outside of Apex, often they get so disenchanted with trying to do all this stuff in the database, they'll actually do mock-ups of data. They'll simply create JSON objects if they're using JavaScript and use mock-up databases to actually provide that functionality. So because it's always been difficult to do before and after imagery of data, people have not done it. They've simply steered clear of it. Flashback makes it trivial. Here's a simple query comparing the department table now to itself as it was, in this case, at 11:51 p.m. So I've chosen a particular timestamp. By doing a full outer join, where I get matches between those two images of the data, one now and one before, that's probably an update if there's been some changes. If it was there 20 minutes ago but not there now, it's a delete. If it's there now, if it's not there now, if it is there now and wasn't there 20 minutes ago, then it's an insert. And I've used that logic to actually put my action column there at the left. So it's a really easy way of doing before and after comparisons without having to actually capture an image of the data before your unit test runs. The other cool thing with Flashback is it is just about querying data. You can use Flashback for even data that's not yours. This is something that we've often done. We obviously should be using source code control, but sometimes we get lazy. What if I drop a procedure in the database, something that my Apex application is using? If I haven't got it in source code control, then number one, shame on you. But if you're caught between a rock and a hard place, well, DDL is just DML in the data dictionary. I could query the DBA source or user source view as of a time in the past before I did the drop. That's an easy way of getting the source data back. DBA source is just a view on top of a table called source dollar. So I'm doing a Flashback query against the source dollar table in the data dictionary. I can do Flashback queries, not just against my objects, but anything I have privileges on. The other cool thing with Flashback is it lets you actually dig even further into the way your data has been manipulated, which once again is very useful for unit testing. If I query the department table as it is now, the department name is unknown. If I look at it as it was 20 minutes ago, it was accounting. Does that mean that someone updated the data from accounting to unknown? Maybe, but maybe not. Was it one change? Maybe there was 100 different updates that went on there. How do we know? And that can be a very useful mechanism of tracking the life scale or the lifespan of a row to see what's going on, especially when it comes to unit and integration testing. We've extended Flashback Query to have a thing called Flashback Row Versions. It's an extended syntax to SQL, the keywords being versions between. So I'm selecting the department table here for all versions between now and 20 minutes ago, but I stress this is one row. This is one row in the table. It's department 10, and we can actually see someone changed it from accounting to money grabbers. Then they updated it from money grabbers to finance, then from finance to bean counters, then from bean counters, and finally to unknown. There's actually been 5 transactions that have updated that department name from the original state of original state of accounting to the final state of unknown. We also throw in some cool pseudo functions to let you get more diagnostic data about those changes. We have version start time, start SDN, etc. To give you an example of what that might look like, here is the same one row, department 10. Now I have the version start time, when that row came into existence, for lack of a better term, when that version of a row. We have the versions operation, that's I for update, that's I for insert, U for update, D for delete. And we also get this thing called the versions XID, which we will come back to. You might have a whole stack of scripts that you run as part of your normal application deployment or your application validation after you've done deployment, etc. You might want to run them now, and you might want to run them at some point in time in the past. You don't have to go and edit all your scripts and add a flashback clause. You don't have to go, oh, here's my 100 SQL statements, go as of 20 minutes ago, as of 20 minutes ago. You can simply set it at session level. You can do DBMS flashback enable and then set a particular time. And then every query you run from that point onwards in that session will actually be a flashback query. That way you can reuse normal scripts, ones that run against the current mode of the data, in a flashback mode without having to do any editing changes at all. Very, very cool. You simply do DBMS flashback disable to get back to the current moment in time. How far can you look back? The examples there, we look back 20 minutes. Can I look back an hour? Can I look back 10 hours? It really depends a lot on the relationship you have with your database administrator. Now, I'm not going to suggest in this picture who is the administrator and who is the developer. That's for you to decide as an attendee on the call. But it comes down to this parameter called undo retention, which is set at the database level. Out of the box, if your DBA hasn't changed it, it is 900 seconds. So that means you'll probably be able to query back around about 15 minutes. I say probably because by default, we are not going to hold on to data at the cost of growing your database. You can actually have that as an option, but that's more in the DBA realm of this discussion. So we're going to try keep 15 minutes, and if we can't, then it'll be less than that. What we generally see is actually, even if you set it to 900, it's generally way more, because if you have plenty of undo table space for that undo information, more than 15 minutes worth, it would be silly of us to aggressively chew up resource to keep it at 15 minutes. So what happens is we have a view called $undo stat, and you'll see in there, there's a value called tuned undo retention. That's a more realistic number of what you can probably flash back to. And even if your database is set to 900, because databases normally have a big, healthy undo table space area, you can typically go a lot further back, and that's the number you can use to decide exactly how far back you can go. That's the end of Flashback Query. That's hopefully our longest one because it's perhaps the most powerful one. Let's move on to Flashback Transaction. I mentioned that we had this thing called a versions XID, this strange piece of hexadecimal that came out with our versions between query. What is versions XID? XID is shorthand for transaction ID. There's no X in transaction, but there we are. If you go look at $transaction, one of the internal database views, you'll see 3 columns, XID, USN, slot, and sequence. It actually is indicative of the fact that a transaction is your ability to get an undo segment in order to hold the undo information. That XID means it's effectively a pointer into the undo segments. And we actually expose that to you with a view called Flashback Transaction Query. If you know the XID, you can get information about the undo information associated with that transaction. So one of the things you can see there, we get when it started, the start SCN, start timestamp, the operation, the table name table, but also this thing called the undo SQL. You can query what the undo SQL would be for this transaction that has occurred. For example, I update the department name, I set it to finance for department number equals 10. If I go get the versions XID from my versions between query and plug it into Flashback Transaction query with XID equals hex to raw, and there's my piece of hex, it says, this is how I would undo that update you just did. I would go to that particular row ID and change the row back to bean counters. It's now at finance. That column of undo SQL suggests that even if I have a committed transaction, as long as I know the XID, the transaction ID, I could actually craft some sort of undo information to roll it back. That's pretty cool because that's like doing a rollback after the commit. And that's what Flashback Transaction is. You don't have to go dig around in that undo SQL. We created a mechanism to do it for you. What's in it for me? Why would I want to undo a transaction that I committed? After all, if I committed it, I wanted to do it. Well, number one is accidents, obviously. The three words that every developer hates or dreads, the three worst words for a developer are delete, commit, and uh-oh. You know, it's funny how that's a really lonely place as a developer. You hit the commit button or you press save, and then it hits you. Like, oh my goodness. And funny enough, even when we know how databases work, we know that commits really do a commit. When you've done a delete and you didn't mean to, the first thing you do is you run a select. Please let the data be there. And you'll always get the correct answer that it is gone. So can we undo a transaction that is already committed? That's what Flashback Transaction is designed to do. Let's roll through an example and see the first pitfall you'll get, but then we'll work through it to a solution. I've deleted this department from the department table and I've committed it. It's gone. There's no more rollback available to me. But I can do a versions between query to get the versions XID. That's what I need to do a Flashback transaction. So I can go get the versions XID using Flashback Query. It's 08, etc., that piece of hex. Then I can run this API, DBMS Flashback transaction backout, and I pass in that transaction name. I can actually pass in an array of transactions, but I'm just doing one. And the great thing is, now that I've got you excited about Flashback transaction, the first time you do this, I just about 99% guarantee this is what you'll see. Your Flashback transaction could not start, at which point, rest assured, you get to wave goodbye to that data. It's gone. Tucked away in the application developer manual in the Flashback section, it says, if you intend using Flashback transaction at any time in the future, you need to have supplemental logging turned on. So you need to do that. And it's not retrospective. Doing that doesn't let you flashback old transactions. You need the supplemental data. Once that's done, then you're ready to use Flashback transaction. Let's roll through that demo again. I've deleted the department. He's committed. I go get the versions XID. I run the API. This time, thankfully, no error. So I'm trying to get department 10 back. I query my department table, and that's when the panic sets in because department 10 didn't come back. Now, you need to keep calm. This is actually working exactly as intended. This is super cool. A transaction could do heaps of things. We've just done a simple delete here, but a transaction could have touched 100 tables, 1,000 rows, lots of things. So just undoing a transaction is a fairly serious activity, and we want to give you a chance to make up your mind. When you start a Flashback transaction, we create what we call a compensating transaction, one that is a new transaction that's going to repair the damage that you did with your original one. We give you that transaction ID from this view, DBA Flashback Transactions. You can now go get a report using that compensating transaction, and it tells you in an XML format, woohoo, XML, it tells you this is what we're going to do. Or in fact, this is effectively what we've done without actually forcing the transaction through. You can see, to get rid of your delete, to undo your delete, we're going to insert the following row. But obviously, if it was a bigger transaction, we'd put a lot more stuff in there. You get to review it first. I get to check, yep, okay, Scott department, one row back in, yep, I'm happy with that. I can commit, and then my row comes back. It's a two-phase process to give you that chance to make sure you really want to go ahead. That's super cool. So that covers accidents. The second one is unit testing. It's so funny how people in the database find unit testing trivial because we have transactional semantics. If you've seen Samuel's PL SQL framework, PL unit testing framework, we have all these wonderful facilities to actually build elaborate unit tests, do them all, and then rely on the transactional integrity of the database to simply roll back at the end and clean up all the mess. The moment you get into more complicated scenarios where you're committing, then yes, you can still use all the unit test frameworks you want, but you're now responsible for cleanup as well. That's pain because that means often half the workload is writing cleanup scripts for the unit tests you've built. And if you're unit testing, for example, things like application express modules, then you've effectively given up some of the control of transactional control. The Apex does it for you. So it's hard to control if you just want to roll back information. So now what you can do with Flashback Transaction is run your tests as before, and all you really have to do is capture the transaction ID. When your unit tests and you allow unit tests to complete, you do your validation, and because they're committed, it makes validation easier. You can have other applications see that data, and then all you have to do is undo that committed transaction with Flashback Query. So, sorry, Flashback Query, Flashback Transaction. Flashback Transaction has now obviated the need for you to have to write cleanup scripts. You just go ahead and do the things of real value, writing unit test scripts, and Flashback Transaction is going to take care of cleaning them out for you. Number 3, Flashback Drop. We might even get done here. Flashback Drop is probably the quickest one we'll do because it's simple and it's unlikely you'll use it. As I said, for developers, the 3 worst words, delete, commit, we use Flashback Transaction for that. For DBAs, 3 words is a blessing. The worst thing for DBAs is 2 words, and that's drop, followed by That's the worst thing. And as I said, developers, we count the data and we find it's missing. As DBAs, when we drop a table, the first thing we do is we go, is it still there? And it's gone, obviously. Funny enough, as DBAs, we then do a second thing normally when we drop a table in production. What we do is we jump onto LinkedIn because our career at this employer has pretty much gone down the toilet. We're probably going to have to find a new job. But luckily, Flashback Drop might be able to save you your career with your current employer. This is the syntax. It's not undrop. Back in the Oracle beta, when this first came out, it literally was undrop. That was the command, but obviously it wasn't as sexy as Flashback Table 2 before drop. If you ever used a PC or a Mac, you're familiar with the concept of the trash can, recycle bin, etc. It's the exact same metaphor here in the database. On your PC or your Mac, all we do is we rename the file to a hidden name. We don't actually delete it, tuck it away somewhere for you to restore. It's exactly the same. We put the object in the recycle bin. And when I say we put it in there, all we're doing is renaming it such that it's hidden from view. We don't move the object, so there's no cost. It's instantaneous no matter how big the object is. You can query the recycle bin to see what's in there. In this case, I dropped the employee table. You can see it dropped the employee table and it dropped the index as well. So everything underneath is gotten rid of. You can also, if you're in SQL CL or SQL+, do show recycle bin. It effectively looks at the same objects. To get it back, we do Flashback Table 2 before drop. That will take that deleted object employee and bring it back to its former glory. If you've already reused that name, I might have dropped the employee table and created a new one. I can flashback the deleted one and give it a new name on the go. I should note that when we drop a table, obviously you drop the indexes, constraints, triggers, etc. And they all get renamed. When you bring a table back, we bring the table name back. We bring all the objects back, but they're not renamed. They'll stay with their deleted names. It's your job to manually rename them. The question is, how long? If I drop a table now, I can probably get it back. What if I dropped it last week and then had an epiphany and went, oh no, I need to get it back, or last month or last year? It's one of those how long is a piece of string kind of discussions. On your PC or Mac, what tends to happen is eventually as your hard disk gets full, you get that little pop-up saying, your hard disk is getting full. Have you thought about emptying your recycle bin? We do the same thing, but we don't do a pop-up. What we do is we will hang on to dropped objects for as long as there is free space in the database. As the database starts getting full, we will silently drop off deleted objects to allow space for new objects. So if your database is running at 99% full all the time, then things aren't going to be hanging around very long at all. They'll be disappearing very fast. If you've got a healthy 20, 30% overhead in each of your table spaces, then what's going to happen is the dropped objects will stay in there for a lengthy period of time. That's pretty cool. But be aware, you don't get to control that. So keep plenty of headroom in your table spaces. I can't stress enough, this is not an untruncate facility. In fact, truncate is far more damaging than drop. Drop a table, get it back. Do some nasty things with transactions, flashback transactions. You cannot, there is no facility in any version of Oracle to untruncate a table. That truncate is perhaps the most damaging thing you can do in an Oracle database. Flashback table, we're getting through them, So what have we spoken about? I've spoken about flashback drop. That's the top left. I drop a table, I can get it back. I've spoken about flashback transaction, where we make a transactional change to a table and we want to undo that one transaction. Somewhere in the middle is if we just make a mess of a whole table. We've done 25 different transactions. I logged on, I ran my huge maintenance script against the wrong database. I ran it in prod, not in test, etc. I've just made a giant mess of a table, lots of transactions. I don't want to have to go find every single transaction and undo them with flashback transaction. So we have flashback table to suit that middle ground. It works very, very simply. We simply say, take the table, flash it back, and nominate a point in time. It literally is that easy. I stress, this is not undrop. This is not flashback to before drop. This is simply rewinding data. Now, what's in it for me? Once again, we're back to the modern development paradigms of the ability to do repeatable tests without needing cleanup scripts. Now I could do an entire suite of integration tests, for example, where I do hundreds of transactions against 3 or 4 tables, the core tables of my application. And at the end of it, I don't have to restore from backup. I don't have to re-import an export file. I simply flash those tables back and I'm good to run the integration tests again. Flashback is awesome for automation of testing facilities because at the end of the test, you simply flash it all back and let the thing run again. You simply test, you commit, flashback to your start point, you're good to go. What a flashback table does is goes and finds all the rows that have been changed since the nominated point in time you want to flash back to and deletes them. And then it inserts them as they should have been to that point in time. So it's a busy operation. Be aware it's going to work hard. It's all done in a single transaction, but you can do multiple tables. So I can flashback department and employee all in one command. And because it is just rewinding data, it's doing what we would do manually if we had to. We're doing deleting all the new stuff, inserting all the old stuff back in. It's really just what we would have to do laboriously by ourselves. At the end of the exercise, your data must still be valid. Your foreign keys must match up, etc. It's not a way of, you're not hacking the data. You're simply rewinding it back to a valid state in the past. One thing that's important is it's about rewinding data. It's not like if you added a column and you flash back the table, the column disappears. Or if you drop a column and you try to flash back the table, you might get an error. Most DDL becomes a boundary to which you can't jump beyond. If you try to flash back a table to a certain point in time and you, for example, dropped a column or you truncated it, you'll get this. Unable to read the data, the table definition has changed. We simply can't do it. Flashback database. So back to our 3 pictures. I've covered flashback drop, we've covered flashback table and flashback transactions. What if you just hose your entire database? You've got 10 schemas, you're doing some massive rollout, and you've just made a giant mess of the whole thing. We have a technology for that too. Flashback database, you might be thinking, is much more in the realm of DBAs. And for giant disasters, yes, that is true, but bear with me, there's going to be some development excitement here in a couple of minutes. What your DBA would do if he wants to do flashback whenever he wants, he would turn flashback on at the database level. And all that does is turn on a brand new background process. We already have the database writer, which writes new blocks to disk. We have the reader, which logs all changes to disk. Turn on flashback mode, and we have a new process which keeps old images of blocks on disk to allow you to rewind the data. But the command is great. It literally is flashback the database to 2 p.m. The database is blocked from use while this occurs, obviously, but once it's done, we open it up and the database is rewound. It's not a restore from backup. It literally is undoing changes using those images kept in what we call the flashback logs. So it's super fast. If you don't know a time, if you're doing things and you want to nominate a time, you don't have to make a note in your notebook. You can create a thing called a restore point. I'm okay so far, and then I can flash back to that nominated point in time. As Apex developers, you're going, yeah, thanks. Joy for the DBAs, but why would I be interested in flashing back an entire database? One, when you come to do deployments, whether you or your DBAs are doing it, this can be really, really cool. Let's do a new application. Now, already the Apex part of any application is easy to undo because it's a single transaction. If you go look at an export file, I've obviously trimmed it right down here, but what we do is we begin the import, we remove the existing application, and then we create the new one with all the metadata, but it's all a single transaction. At the end, we commit if it worked and roll back if it didn't. So the application express deployment part of a rollout is a one single transaction, no big deal. It's going to work or it doesn't. But of course, we very rarely roll out just an app. What we do is we roll out DDL associated with, we create new tables, we add columns, we drop columns, we create new versions of packages and everything. We do a lot of stuff outside the remit or the umbrella of our Apex application. And all of that would need to be undone as well if your deployment went pear-shaped. So we have this thing of 9 o'clock, we start this massive deployment, we've kicked everyone off, for example, and we're doing our big deployment, all the DDL, and what happens at 9:40? You know, when the proverbial hits the fan. The cool thing is, rather than having to undo it manually and have enormous outages, you simply can flash back the database to 9 o'clock. I would create a restore point at 9 a.m. and flash the database back. The deployment is undone, and we're good to go. We're good to move forward and have a post-mortem. The other cool thing is repeatable end-to-end testing. And I want to show this diagram. When a multi-tenant system, we can have multiple pluggable databases. Now, the cool thing is, if I have multiple pluggable databases, I can give developers their own pluggable database. And the cool thing with that is, I can flash back at the pluggable database level. So now I can give a developer, for example, a copy of my central development database. I can give him a private sandbox, his own pluggable database, plugs it into the database running on his laptop. He can now flash that back. He can run a test, flash it back. He can build a new version of application, doesn't like it, flash it back. He can do deployment testing. He can do anything he wants. And every time he wants to go back to the starting point to effectively resync with the development database, that's the central one, bang, flash back the database. One little detail that's critical of that diagram. Here's the diagram again. Let's talk about how we can do this, because you might be thinking, yeah, great. What's it going to cost to have a database for every single developer in my organization? Well, you can give them all XC. That is 100% free. Unlimited versions, no restrictions, no nothing. Have as many versions of XC as you want. Zero cost there. 19C, 3 pluggables, 3 copies of your development database on that machine, 0 multi-tenant license costs. Doesn't cost you an extra cent over your standard Oracle license you already got for running Apex. So I can have 3 pluggables, I can have my main development, I can have a branch, I can have a refreshable clone that I wanted to give out to developers. What about the pluggables sitting there? How am I going to plug them into XC? Well, don't forget, XC is complete enterprise edition features. Therefore, you also get multi-tenant with pluggables for no license fee on XC. That whole infrastructure where you give your developer, every single developer, a copy of their development database that is refreshable and a private sandbox that they can refresh in isolation away from the main development branch. You can do the whole thing for not a single extra cent. Blows my mind. It's amazing. The other cool thing with Flashback Database is more of a hidden one, is you can now give developers production data if they so need it. Because one of the things we do with standby databases, this is in the realm of DBAs, is a standby database can be converted to what we call a snapshot standby. And what that does is breaks its link with production and makes it a read-write copy of production. The cool thing with that is it doesn't break the link permanently. An administrator can put it back into normal standby mode. So as a developer or a DBA, if you want a copy of your production system that you can do read-write operations on without damaging your real production system, test a deployment, test a patch, test some Apex stuff, you could do it with a snapshot standby. Under the covers, we're using Flashback Database to rewind it back and put it back in sync with your normal production database. Very cool. One more feature left, and I think we might even get it done on time. Flashback Data Archive. Now, this is It's a flashback technology, but it's less about flashback, more about archiving here. One little drink. The first thing you need is some space for our archive. So we create a table space. Your DBA can do this for you. Then we have this new object called a flashback archive. We attach it to that space that's being created. We need some space. But the key clause here is we nominate what we call a retention period. This particular archive called long-term, I've said I'm going to hold data in there for 1 year. What I'm saying is that any object I put into this flashback archive, I'll be able to see what that table looked like at any point in time up to 1 year in the past. Hugely more, obviously, than the under retention of 15 minutes. So I grab my employee table and I put it into this flashback archive, and I do lots of DML, inserts, updates, and deletes. I can obviously query it as it was a normal table. There's nothing changed there. We haven't changed the table. I can query it and it just does a read of the table. I can query it as of an hour ago. This will use Flashback Query that we covered right at the start of this session. An hour is probably in my under retention period. I can probably just do that and undo an hour's worth of transactions. So I'm just querying the employee table. What happens though if I wait for 3 more days and then say, show me the table as it was 3 days ago? You can see under the covers, there's a whole lot of stuff going on here. Yes, we're reading the employee table, but we're reading some other tables as well that have seemed to be come magically into operation. What's in it for me? You know, we're not going to cover the internals. Why would I want to? I mean, this is the most common response when I talk about Flashback Data Archive. People say, I really don't care what the flashback table looked like in June 2019. Why would I have an interest in that? Where's the use case? But think about it for a second. If you can see the table as it was in June or March or 2 p.m. Wednesday or any time, what you've really got is every historical version of every single row available to you. Now that sounds a whole lot more familiar, because one of the common things we have to do as developers, we often get asked to do, is to build an audit history on all our objects in our database. We've all done this thing in the past where I've got a table called T, and then late in the project, someone says, we need to capture every change. And so we go add some modified bars, and creator bars and timestamp columns. We have a partnering table, in this case called T_audit. And then what do? We whack a trigger on T. And every other table, every time you insert or delete or update, we copy the information over to the audit table. We've all done it. It's common as it works, but it's slow. It's a trigger on every table. It's code maintenance. It's a whole lot of stuff. And why wouldn't you use Flashback Data Archive? Because you get all of that with no triggers. All I have to do to see that historical version is use the versions between, as we saw with Flashback Query. When I have a table in a Flashback Data Archive, that versions between can now go back up to the retention period. I can get a year's worth of audit, and simply using versions between gives me the insert, the operation, etc. As long as you're on 12 or above database, you can capture additional information as well, like the who and the when and the why and what, etc. A whole lot of stuff, what machine they're on, etc. So why didn't we? I mean, as I said, Flashback Data Archive's been out since 2001. How come we still have 1 million audit triggers floating around in our systems? Here's the reason. It used to be separately licensed. You had to pay for Flashback Data Archive. I can't stress this enough because this one flew under the covers. Flashback Data Archive is now free. You don't have to pay any extra license. That's not a typo. Now, I know you're at the point of the presentation here, we're going, my goodness, he's talked about free pluggables, free XE, free this, free that, etc., and free Flashback Data Archive. I know it's an Oracle guy doing this, but it's not a typo. We do a lot of free stuff nowadays. You know, it's so much goodness out there. It's awesome. You only ever have to pay for Flashback Data Archive if you're going to use advanced compression facilities to have your audit really, really compact. I would be willing to wager no one's been doing that with their trigger-based solution anyway. So you get to choose your cost. You can have it for free, and it's just as good as your auditing option, or if you want really ultra audit performance, you can compress it and pay the additional fee. So think about Flashback Data Archive. There's a lot of fantastic goodness in there. It's secure. It's not like your triggering tables and your audit tables are sitting in the scheme like that. They're secure. They're internal tables based on Oracle. It's read-only data. It's very efficient because we're not doing triggers. There's actually a process in the background managing the Flashback data archive. Now you're thinking, yeah, thanks a lot, Connor. I've built my trigger system. I deployed this 15 years ago. You're telling me I have to start as fresh? What about all my existing audit information? You can import that. You can actually take your existing audit information and import it into Flashback Data Archive to generate the historical information, and then you can use Flashback Data Archive to move forward. So let's wrap it up. 8:46, your beauty. We've talked about Flashback Query, Flashback Table, Flashback Drop, Flashback Database, Flashback Transaction, Flashback Data Archive, all really cool facilities, not just for emergencies, but for the modern developer who wants to do continuous integration, continuous deployment, automated unit testing, automated integration testing, wants to give developers a private sandbox of not just their applications, but of their entire database as well. And they want to do the whole thing for not a single extra cent because it's all included in an Enterprise Edition. You don't have to pay anything. Super cool. We are done. As I said, please reach out to me on Office, on my blog, Twitter, etc. We live in a virtual world now. A lot of our sessions obviously are done virtually. Don't forget the asktom.oracle.com/office hours. We've been doing virtual now for 2 years. We've just ticked over 350 online events. So we'd love to see you on them. We have Apex ones, but millions of other pieces of tech as well. I'm done. Thank you very much. If you have any questions, fire them through. If I can't get them answered tonight, I'll certainly answer them via blog post or similar.
Well, actually, your time is over, but well, we still have time for a big thank you, Connor. It's great to see you alive and kicking, and your house not being torn down. There are some questions. Mainly, people can't believe the free thing, and there are some, well, detailed questions. I will send them to you afterwards, so you can
I'll
answer
blog
them.
post on them, and I'll get them all settled out. Yep.
Yep, fine. So, well, thanks a lot. And
thanks, everyone. Have a great rest of the conference. See you, Sabina.
Bye.